So let's say that we're going backwards. Okay, this is called the decomposition of functions. Okay, so we're going back. Before it's called the composition of functions. Now we're going to call it the decomposition of functions. I'm going to do this in green. Okay, so let's say that they start. Okay, let's say that they start by giving you this. Okay, let's say they give you an equation that looks like, they call this h of x. Okay, they call that h of x. And they basically asking for f of x equals 2 and g of x equals 2. Okay. All right. So h of x, which is basically equal to f of g of x, by the way, which is equal to that thing on top. Okay. It's basically equal to that thing on top. Let me just make sure the directions are matching. Okay. So either they could phrase it as this is h of x, okay, or let's just not make it confusing. Let's just call it f of g of x. Okay. So ignore this h of x thing. Okay, don't even worry about that because I don't want to throw too much at it. It's really easy. Okay. So let's say that f of g of x is this whole thing up top. What's g of x? What's f of x? Okay, that's basically the question at hand. I like to start inside, work my way out. Okay, it doesn't matter. Okay, by inside, I'm going to look at the quote unquote smaller function. What's the smaller function or the embedded function? The function that's embedded. Okay, the function that's embedded, which is g of x. Okay, I like to call g of x the embedded functions. Embedded function. Okay, g of x is embedded, and the yellow highlight is the embedded function. Okay, so I like to call that negative 3x plus 4. So ask yourself, what's the embedded function? That is negative 3x plus 4, which is g of x, and that is embedded within what bigger function? Okay, what quote unquote bigger function? Okay, it's embedded within x squared minus 2x plus 1. Okay, because remember, this is a big fat x. Okay. All right. So let's use that same logic. Okay. Let's use that same logic here. Okay, for example, 2 and 3. All right. So let's say you have something like, let me blow this up. Boom, boom. Copy that. Paste it here. Make it bigger. Okay. So let's say let's say that you don't know any of this. Okay, and the only thing that you know are the highlights here and here. Okay, but let's start with the first highlight. Okay, now f of g of x. Okay, now there's not only one right answer, but typically people usually get the same answer. I like to call this the embedded function. Okay. I'm going to actually write f of g of x over here. Okay. Yeah, let me make it like this, actually. Okay. Why is my computer super laggy right now? So let's call this f of g of x. Okay, the embedded function, okay, is g of x. And the embedded function, I like to call it square root of x. That is embedded within f of x. That's embedded within the bigger function of e to the power of x. Okay, because we're substituting, again, remember, we're substituting this square root of x into x. Okay, so we're embedding square root of x into that x. Okay, or substituting, whatever word you want to use. Okay, and that's the yellow highlight there. Now let's take a look at this blue highlight. All right, and how we're going to do that. Again, the embedded function in this case, I like to go, I would go g of x, the embedded function is e to the power of x. We're embedding that within the bigger function of f of x, which is root x. Again, we are embedding or substituting that e of x, or e to the power of x, into that x right there. Okay, so again, the big picture is that we're going backwards now. They're giving you f of g of x, okay, and then you're finding out f of x separately and g of x separately. I should state in the order I did it. You're finding g of x first and then f of x second. Okay, it doesn't matter what order. I just like to do it like that. Okay, so that's why it's called a decomposition of functions. We're decomposing this into g of x and f of x. Okay. All right, let's do one more example. Okay, I know it can be overkill, but I'd rather be safe than sorry. Okay, I'd rather be safe than sorry. So let me see if I can go through this quicker. Okay, I'm going to cross that out, f of g of x, f of g of x. Okay, now I'm going to call this the yellow highlight. All right, and I'm going to say g of x. And again, this is the embedded. I'm going to call that x squared minus 1. And we're going to embed that within the bigger function of square root of x. Okay, so we're going to embed that. Let me draw 2 circles here so you know exactly what I'm embedding. I'm embedding this x squared minus 1 into that x. And that's what gives me this yellow highlight here. Okay, let's use that same logic over here. Again, this is probably overkill, but screw it. I want to rather be safe than sorry. And this is going to be x squared. I'm tripping out. Sorry, g of x. We're going to embed that within. And we're going to call that root x. And we're going to embed that within the bigger function of x squared minus 1. Okay? Boom. Embed that to wherever you see this x right here. That's it. Okay? I want you guys right now. Okay, that pretty much wraps up the lesson. Okay? I want you guys right now. Let me throw in a blue highlight. Okay, just because I like to color match my things. Okay? I want you guys to go ahead and do the problems that I'm going to highlight